Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syaahiir bin Muhammad Rizwandi. So in this video I'm going to explain about assignment ELE242. In this assignment we are given 4 questions that we need to do the simulation for this question and also the theoretical solution to get the result. Okay, next let's get the question. This is this question 1. Okay, the question 1 said figure Q1 shows a subtractor circuit. Assuming the op-amp is ideal, determine the output voltage. Okay, this is output voltage. Okay, I will do the simulation. So the first one is we take the op-amp and then okay, as you can see here the polarity is different, so we need to flip vertically. Then we take the resistor basic resistor 1k. Okay, 1. We need 4 resistor here, 2, 3 and 4. Okay, we need to rotate 90 and we do the connection here. Okay, alright. Then for the V out we will put the multimeter to get the measurement. Okay, and then we need to take the DC voltage under sources. Where is power source? DC power. Okay, sorry, DC power. Okay, 1. We need 2 DC power and 2. Okay, after that we do the connection. And we need 4 ground here. Take ground. Take 1, 2, 3 and 4. Okay, then connect them together. Alright, and then for the 7 and 4 segment, we need to put the VCC and VEE. So we take VCC under source, under power source, VCC for the positive side, and VEE for the negative side. Okay, we need to flip this vertically and then connect them. Alright. Okay. Now we need to change the value for all the components. Okay. This is 10 volt, and this is 9 volt. For this resistor 1k. This is 2k. Okay, this is 1k. Okay, for the VEE and VCC, we need to put the greater value from our source, our DC source. So as you can see here, this is 10 volt, so I will put 15 volt here. This is also 15. Alright, so we already complete construct the circuit. Okay, now we will simulate the circuit, and then we get the result -4. Okay, after we already do the simulation, for the question 1, we will compare the result with the theoretical solution for question 1. Okay, let's see here. Okay, the first step is we need to find the V plus of the op-amp. Okay, we use the formula of voltage divider rules. We take the 1 resistor over 1 kilo resistor plus 2 kilo resistor here times 9 volt. Again, we get 3 volt. Okay, as we know, V positive equals to V negative equals to 3 volt. So this is 3 volt, and then to find the V out, we use the formula current in equals to current out. So current in, V in minus V negative, and then over this the value of resistor here. So equals to V negative minus V out over RF, which is 1K. So 10 minus 3 over 1 kilo equals to 3 minus V out over 1K equals to 7. 7 equals to 3 minus V out, and then we get the answer for V out is negative 4. So the value of the theoretical solution and the simulation is same. Question 2. The question 2 says figures Q2 shows a combination of two operational amplifier circuit. Determine the output voltage of V out 1 and V out 2. Assume all of them are ideal. Okay, first step is we need to find the op-amp that we use, which is ELE242. Okay, we need two op-amp. Take two op-amp, and then we change the polarity of the op-amp. Flip vertically. No. Wait, undo. Flip vertically. Okay, and then we take the resistor. Resistor under basic. Resistor 1K. Okay, we need how many resistor? 2, 3 here, 4 here, 5 here, 6 here, 7 and 8 resistor. Okay, then we will connect the resistor with the op-amp. Okay, flip 90 degree. Will connect here, and this will connect with the negative segment of the op-amp, and then this will connect here, kemaskan, and okay, after we done construct the circuit, we need to change the value for all the component due to the given circuit. Okay, for the voltage value is 5 volt, and then here is 3 volt, and then the resistor is 120k. It's big, 20k, and this R1 is 30k, and R3 is 300. Okay, for the R4 is 18k, and R6 is 27k, and R7 is 56k, R5 is 20k, and this voltage V3 is 0.7 volt, and R8 is 15k. Okay, then we need to change the value of VEE and VCC bigger than the DC power. Okay, this I will take the value of 20. Okay, after we change all the values, we will simulate this circuit. Then we get the result is negative 10.021 volt. We will do the theoretical solution for question 2. Okay, this is the question. We need to find the V output 2 here. Okay, first one is I will separate the circuit first. Okay, this circuit we will find the value of V output 1 first. Okay, as usual we will find the V positive. We use the formula of voltage divider rules. Okay, we take the 18k over 18k plus 30k resistor here and times 3 volt, and then we will get the value of V positive. And then as we know, V positive we will equal with V negative here, and then the value is 1.125 volt. Okay, then we will find the V output 1 here. We will use the formula of current in equals to current out. Okay, for the current in, this here 5 volt will minus with V negative, which is 1.125 over resistor 120k equals to V negative 1.125 minus V output here over 3 this resistor, which is 300k. Okay, after the calculation we will get the V output 1 equals to negative 8.563 volt. And then after we get the value of V output 1 here, we will do the second circuit after we separate. Okay, this is the second circuit. Okay, as usual we will find the V positive. I call it V positive 2 because we already have V positive 1 here, so this is V positive 2. Okay, for this question we need to use the superposition theorem. Because of why we need to use the superposition theorem? It is because in one circuit we have two source. Okay, in one circuit, so we need to in superposition theorem, the method is we need to only one source can be activated, can be turned on in one condition. So we will have two conditions here. The first condition, we will turn on the V output 1 first, so we get the value of V positive 2 equals to negative 3.67. and then for the second condition, we will turn on the 0.7 volt source, and then we get the value of V positive 2 equals to 0.4. After that, we will total up the value of V positive 2 equals to negative 3.27 volt, and then as usual, V positive 2 will equals with V negative 2, and then the value is negative 3.27. Okay, after that we will calculate the value of V output 2 here using the also same formula, which is current in equals to current out. So our current in is 0 because this circuit is connect with ground, so 0 minus value of V negative, which is negative 3.27 over 27k. Okay, equals to negative V negative, which is negative 3.27 minus V output 2 over 56k. And then after the calculation, we get the value of V output 2 equals to negative 10.052. Okay, for the value of theoretical solution and the simulation result is in the slightly different. Is because for the simulation result, the components have the internal resistance. Okay, so the value might be slightly different with the theoretical. Okay, we go to the question 3. So question 3 said figures Q3 shows an instrumentation amplifier circuit. Calculate the output voltage V output. Assume all op-amp are ideal. Okay, for the question 3, I will not show the simulation, but I already do the simulation and put the circuit and result here. So as you can see here, the result for the simulation, we get negative 17.748 volt. Okay, we go to the theoretical. Okay, for the theoretical solution, I also separate the circuit. For me, it will be easier for me to calculate the value. Okay. The first part is I will take this first op-amp to find the value of V output 1. Okay, as usual, to find the V output 1, we will use the formula of current in equals to current out. So our current in is here is V output 1. Okay, V output 1 minus with voltage supply equals to it equals to 10 over 1.5k here. Okay, why our voltage supply we take the value of 10, because as we know, V positive here will same value with V negative. Okay, V positive 10, so the value of V negative also will be 10 and bring up to this node. Okay, this node will be 10 volt. Okay, so equals to 10 minus 5 volt here over 1.2k. So after do the calculation, we get the value of V output 1 equals to 16.25. Okay, for the second op-amp, I also separate the op-amp. So to find the value of V output 2, we will do also the same method, which is current in equals to current out. So we take the value of 10 volt here minus 5. Why we take the value of 5? Because also the same, V positive is 5 volt, so V negative here will be 5 volt. So and then bring the value to this node. So we get the value of this node is 5 volt over 1.2k equals to 5 volt minus V output 2 over 1.5k resistor here. So after do the calculation, we get the value of V output 2 equals to negative 1.25. Okay, after that we do the calculation for the last op-amp. So we already get the value of V output 1 and V output 2 here. So the first step, as usual, we will find the value of V positive. Okay, V positive, we use the formula of voltage divider rules, and then we get the value is negative 0.75. So as we know, V positive will same value with V negative equals to negative 0.75. So after that, we also use the same method, which is current in equals to current out. So V output negative V output 1 minus V negative equals to R1. This is R1 and V equals to V negative minus V output 3 equals to RF, which is 18K. So after do the calculation, we get the value of V output 3 equals to negative 17.75. Okay, if you can compare the result for the theoretical and the simulation, it will be the same, negative 17.75. Okay, for the question 4, the question said calculate the output voltage of V output 1, V output 2 and V output 3 for the circuit shown in figure Q4. Assume all operational amplifiers are ideal. So also for the question 4, I will not show the simulation, but I will already put the simulation circuit and result here. So as you can see here, the result for the simulation is 7.333 volt. Okay, we will compare the value of this simulation with the theoretical solution. So for the theoretical solution, also I will separate all the op-amp to get the value of V output 1, V output 2 and also V output 3. Okay, for the V output 1, we use the method of current in equals to current out. So here we have two current in here, which is I1 and I2. So I1 will plus with I2 equals to I3. So as we can see here at the op-amp, V negative here is connected with ground, so the value is 0. So the value of V positive also will be 0. So we'll do the calculation. 2 volt here will minus with 2k resistor here, plus with 4 volt here and over with 2k resistor here, equals to current out, which is 0. This is 0. This not will be 0, negative minus V output 1 over RF, which is 1.5k. So after the calculation, we get the value of V output 1 equals to negative 4.5 volt. Okay, for the second op-amp, the second op-amp is very simple because there is no resistor here. Okay, as we can see here, this value of V negative is 2 volt, so the value of V positive also will be 2 volt. So V output 2 will be 2 volt also. Okay, for the V output 3, we can see here the value of V positive is connected with ground, so the value is 0. So if the value of V positive is 0, the value of V negative also will be 0 at this node. Okay, this node is 0. So also the same, the method used is current in equals to current out. So but in this situation also we have two current in here, which is I1 and I2. So I1 will plus with I2 equals to I3. So we take all the value, which is 2 volt over 2.5k resistor here, plus negative 4.5 over 1k volt 1k resistor here, equals to this node 0 volt minus with V output 3 over 2k resistor RF. Okay, after do the calculation, we get the value of V output 3 is 7.333 volt, same value with the simulation result here. Okay, I think that's all for me for this assignment. Thank you.